Well, there's a red dot on, so.
Okay, I think we may be recording. Okay, so, go ahead.
Okay. We have a little change of pace today, class. For the sake of tradition, I'm going to say I'm going to try something experimental. So we're going to investigate the surface z equals x squared plus minus 4y squared. And we wish to study its level curves and plot the gradient field. Well, there's going to be very little like actual writing math today. I just want you to understand visually what the gradient means. Okay, so we have this surface, and we first note that we can express this surface as a graph. We set fxy equals x squared minus 4y squared. Okay, so we have our surface expressed as the graph z equals 4fxy. Okay. So is this something that is controversial to any of you? Yep, see. Okay, so let me see, it's like this. It's a function definition. So we take the usual gradient formula. Okay. And you remember what the gradient is, right? The first variable is the derivative in terms of x, and the second variable is the derivative in terms of y. So do any of you, do both of you see, do all of you see that?
Yes.
Awesome. Great, so we're on the same page. The algebra is boring. Let's see some pictures. Let's have a look at the level sets.
What's a level set?
You've done this before.
Okay.
Yes. Okay, so
I'll tell you about level sets.
let's pick some level sets. So what level sets do you want to pick? So we have our function x squared minus 4y squared equals z. Right? So we can pick our level sets to be numbers here. What are your favorite numbers this time?
0,
Okay, let's try that. Two more.
1,
Okay.
4.
0, 1, and 4. Awesome. Okay, so let the magic begin. Let the magic begin. Ooh, okay, so you see, the order these are in there is red, green, and blue. So red refers to the 0 level set, green refers to the 1 level set, and blue refers to the 4 level set. Okay? Yeah, I will note that Natalie chose poorly, since this isn't actually like, there's a little bit of a messiness in the center. That isn't actually how that red level set looks like, but it's close enough. Okay. So this is what a level set looks like. And I want you to think of these as a topological map. If, let's say you're hiking up a hill, right? So that red line is sea level. The green line is say 100 meters, and the blue line is say 200 meters, or 400 meters. That's the way I want you to think. And you guys remember what the gradient is?
2x minus y.
Yes, I mean, yes. What does the gradient represent? What does it mean to you, Aru?
It's the derivative.
It means that calculation that I did, that I'm going to do wrong.
That is not incorrect, but there's another thing about it. The gradient field represents the direction in which this little hill, represented by the surface, is the steepest. Right? So, yes?
That doesn't make any. Why is that? I don't know.
That's just
Why?
that's the definition of the gradient, and we will think of it's related to the derivative. The gradient is basically the three-dimensional version of the derivative, and when the derivative is large, the gradient the slope is steep. In the same way here, I mean when the gradient vector has a large magnitude, the hill is steep. Similar idea, but it takes some getting used to. Okay, so let's plot this little thingy now. And this is what it looks like. I want you to notice a few things here. Notice how the gradient lines are close together over here, right? And notice how the gradient vectors are large in the same area.
They're all. Wait, the gradient lines are all equally close together.
No, I mean, notice the vectors up here
Yeah.
have larger magnitude than the vectors in here. You can barely see them, right?
Yeah.
And notice how these correspond to level sets that are close together. Level curves that are close together. And it makes sense because you're going from like 0 meters to 100 meters to 400 meters very quickly. It's very steep. Here you're going from 0 meters, 100 meters to 400 meters very slowly, and thus you have tiny gradient vectors over here.
I thought the 0 was the blue.
0 is red, green, and blue. So, and notice also that all the vectors are pointing uphill. Right? So this is precisely what you should think when you do the gradient. I mean, you know how to do the calculations already, but this is what you are really doing. I have a little bonus picture for you. Okay, but before we begin, before I show the surface, can anyone describe to me what you think the surface looks like? Based on level sets and based on the gradient field. Hyperboloid, yeah, it kind of is, but you can see a few things. So this represents how steep it is. So you can see that the surface is very steep here. It's a very steep curve here. It's a very steep curve going that way. And it's a very shallow curve in between. Can you see that? So remember, big arrows means steep. Little arrows means shallow. Okay? So keep that picture in mind as we show you the full 3D picture. Okay? Remember that little shallow curve in the middle where the little arrows were, and the steep curve at the side, at the top and bottom where the big arrows were. This is your hyperboloid in all its glory.
That's not a hyperboloid.
Right? It is, right?
No,
No.
it's
Oops.
closer to the saddle.
It's a saddle, yes, but isn't that type thing hyperboloid?
You'd have to zoom out.
Yes, right. Okay, I'm done. Awesome.
Well, register to class.
Yeah. Yeah.
Sorry.
I thought this kind of was a hyperboloid. I'm not sure.
But they're like this, aren't they? Or maybe they're too close together, so you get a one sheet.
Yeah, this has one sheet, but that's okay. It's what's
My
acceptable.
dad usually calls it hyperboloid of one sheet.
Okay.
Yeah.
There's also the hyperboloid of two sheets. Hyperbolic parabola.
Nothing too embarrassing my desktop, that's awesome.
I don't think my dad has ever called it that.
Okay, so like 1 minute for comments and then next one.
You're propagating the misconception that topology has to do with mountains, and I'm very
I
disappointed.
said topography, right? I didn't say that.
You said topology.
Oh gosh.
You said, think of this as a topological map. No,
Oh dear.
no.
I heard that and then I was really worried, but then you went on into something reasonable. I was like, okay.
Please don't think about it as a topological map.
Okay, in my defense, English is my first language.
No, that's not going to be a good excuse anymore. Absolutely not.
All right.
Okay, next volunteer.
That would be usual people's taxes, you know.
Wait, you
Things
said
like-
you
Turn
had
the
the
lights.
same circuit.
I can go if you want.
Okay, David's volunteer to go next.
He probably going to steal my lecture too.
So I'm not sure how to get that thing to go up. We should follow.
There's that button.
Oh, sorry.